Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today we're diving into computer vision frontiers, examining 115 groundbreaking papers published on August 11, 2025. This episode takes us through the latest advances in machine perception and understanding, from revolutionary generative models to life-saving medical applications. We'll explore how machines are learning to see, understand, and create visual content with unprecedented sophistication, revealing the research landscape that's reshaping our digital future. Our journey today follows a structured path through visual AI innovation. We'll explore 6 dominant research themes that are shaping computer vision's future, from advanced generative models to multimodal integration. We'll examine the breakthrough methodologies that are accelerating practical AI deployment, making these technologies more accessible and efficient. Then we'll dive deep into 3 seminal papers that demonstrate field-defining innovations, before concluding with key findings that are transforming how machines see and understand the world around them. Finally, we'll look ahead to future directions for visual intelligence research. Computer vision represents one of the most transformative disciplines in modern artificial intelligence, enabling machines to interpret and understand visual information from the world around them. This field powers the autonomous vehicles navigating our streets, the medical imaging systems helping doctors save lives, and the augmented reality applications transforming how we interact with digital content. Computer vision is inherently interdisciplinary, combining mathematics, neuroscience, and computer science to solve problems that humans perform effortlessly, but machines find remarkably challenging. The field has experienced explosive growth driven by deep learning advances, massive datasets, and increasingly powerful computational resources, evolving from simple pattern recognition to sophisticated visual understanding capabilities. The first major research theme centers on advanced generative models and controllable content creation. Researchers are developing increasingly sophisticated methods to create and manipulate visual content with unprecedented precision and control. John and colleagues' work on training free occlusion control in image generation demonstrates how we can precisely control object relationships in generated images without requiring expensive model retraining. Meanwhile, So and team's Grouped Speculative Decoding achieves a remarkable 3.7 times speedup in autoregressive image generation while maintaining quality. These advances address one of the most pressing challenges in making generative AI practical for real-world applications, enabling sophisticated visual content manipulation without the computational overhead traditionally required. The second prominent theme focuses on three-dimensional understanding and spatial intelligence, representing a critical evolution from flat image processing to rich spatial perception. This transition enables machines to understand depth, volume, and spatial relationships more accurately than ever before. Gia and colleagues demonstrate sophisticated approaches to multi-view surface reconstruction using Gaussian Splatting techniques, creating detailed three-dimensional models from multiple camera viewpoints. Wang and team show how we can manipulate three-dimensional content through multi-view diffusion models, enabling 3D content editing with the same ease we edit traditional images. This volumetric understanding represents a fundamental shift toward machines that can perceive and interact with the world in truly three-dimensional terms. Multimodal integration and cross-domain learning emerges as the third significant theme, reflecting how modern computer vision systems increasingly need to process multiple types of information simultaneously. These systems combine visual data with text, audio, or specialized sensor information to create more comprehensive understanding. Yang and colleagues' work on visual robot manipulation, learning from human demonstrations, showcases this beautifully, demonstrating how human action videos can inform robotic manipulation tasks. This bridges the gap between human demonstration and machine execution, creating unified architectures that naturally process multiple modalities simultaneously, rather than treating different data types as separate entities requiring complex fusion mechanisms. Analyzing these papers reveals several transformative insights that are reshaping the field. First, image tokens exhibit fundamentally different properties compared to language tokens, with significant implications for how we design acceleration techniques. Unlike text, where there's typically one correct next word, visual content allows multiple valid representations of the same concept. Second, training-free methods are enabling sophisticated visual effects without requiring expensive model retraining, making advanced capabilities more accessible. Third, uncertainty estimation has become crucial for real-world AI deployment, helping systems know when they might be wrong. Finally, cross-modal learning is enabling knowledge transfer across domains, allowing AI systems to leverage diverse sources of information for more robust and adaptable performance. The methodologies driving these advances reveal several core techniques that have become fundamental to modern computer vision research. Contrastive learning has emerged as a powerful approach for learning meaningful representations without explicit supervision, teaching models to understand what makes different images similar or different. Gaussian splatting represents scenes as collections of three-dimensional Gaussian functions, offering differentiable rendering capabilities and efficient representation of complex geometries. Diffusion models continue to dominate generative tasks, excelling at generating high-quality, diverse images by learning to reverse a noise corruption process. Transformer architectures have largely replaced convolutional neural networks, excelling at capturing long-range dependencies. Graph neural networks are gaining traction for spatial and relational reasoning tasks. So and colleagues present Grouped Speculative Decoding for Autoregressive Image Generation, addressing one of the most pressing challenges in modern AI, the computational bottleneck of autoregressive image generation. Their key insight is that image tokens behave differently from language tokens in ways that create unique optimization opportunities. Visual content exhibits inherent redundancy and diversity, meaning multiple tokens can represent valid semantic content for the same spatial location. Their methodology evaluates clusters of visually valid tokens rather than single target tokens, asking whether a proposed token belongs to a cluster of visually acceptable alternatives. This approach achieves a remarkable 3.7 times speedup across different autoregressive image models, while maintaining quality, requiring no additional training for existing models. Yang and colleagues present MATRIX-3D omnidirectional explorable 3D world generation, tackling one of the most ambitious challenges in computer vision, creating immersive, coherent three-dimensional environments that users can freely explore. This work overcomes fundamental limitations of existing 3D world generation approaches, which typically suffer from restricted scope and break down when users attempt to explore from different angles. Their trajectory-guided panoramic video diffusion model employs scene mesh renders as conditions, enabling generation of high-quality and geometrically consistent scene videos. The Matrix Pano dataset comprises 116,000 high-quality static panoramic video sequences, with depth and trajectory annotations. Applications include virtual reality experiences generated from text, descriptions, architectural visualization tools, and educational content allowing immersive exploration of historical locations. Chang and colleagues present SOFA, Deep Learning Framework for Simulating and Optimizing Atrial Fibrillation, ablation representing a remarkable example of how computer vision techniques can directly impact healthcare outcomes. Atrial fibrillation affects millions worldwide, significantly increasing stroke and heart failure risk. The SOFA framework addresses whether we can predict atrial fibrillation recurrence by simulating different procedural parameters and how ablation procedures should be optimized to minimize recurrence risk. The system combines simulation, prediction, and optimization in a unified deep learning framework, treating the ablation procedure as a controllable image transformation process. Using cardiac imaging, the system can optimize ablation parameters including location, duration, temperature, power, and catheter force, potentially transforming clinical practice by providing physicians with data-driven guidance. Looking toward the future, computer vision research faces both exciting opportunities and significant challenges. The architectural evolution from convolutional networks to transformer-based approaches represents a fundamental shift in how we process visual information. Several key directions emerge as particularly promising. Developing more efficient architectures that deliver state-of-the-art performance with reduced computational requirements will be crucial for democratizing access to these technologies. Enhanced robustness and domain adaptation capabilities will enable seamless adaptation to new conditions without extensive retraining. Deeper integration with robotics and natural language processing will create more comprehensive and capable systems. Improved interpretability for critical application deployment addresses growing needs for understanding decision-making processes. The democratization of advanced computer vision technologies continues, making these capabilities accessible to broader user communities. This comprehensive analysis was created using advanced AI synthesis techniques to provide you with accurate, up-to-date insights from the latest computer vision research. Content was synthesized using GPT and Anthropic Claude Sonnet-4-2025-0514 language models, ensuring comprehensive coverage of technical details while maintaining accessibility. Text-to-speech synthesis was powered by Deepgram technology for natural audio delivery. Image generation was enhanced through Google AI tools to create supporting visual content. Human expert review was conducted throughout the process to ensure accuracy and coherence. While we strive for complete accuracy, potential oversights are acknowledged and all references are provided for your independent verification and deeper exploration of these fascinating research developments. Subscribe to our YouTube channel for cutting-edge AI research insights and never miss the latest developments in artificial intelligence. We provide weekly deep dives into the latest computer vision breakthroughs, expert analysis of emerging trends and technologies, and comprehensive coverage that helps you stay ahead of the curve. Join our growing community of AI researchers, practitioners, and enthusiasts who rely on AI frontiers for their daily dose of innovation. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archivepreprinserver.org, content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archivepreprinserver.org.